So we'll begin with the session. So first of all, we'll understand what is our objective for today's session. So in today's session, we are going to understand what is basically memory forensics. Why do we need to acquire the memory? What are the advantages of acquiring memory from a system? What are the fundamentals of memory forensics? How do we acquire the memory? What are the steps in memory forensics that we need to keep in mind before we start acquisition of a memory? What is live memory acquisition? How memory acquisition is affected? What are the factors that are affecting the memory acquisition? And how do we decide that when and how we need to acquire the memory? And at the end, we'll move ahead to the software tools. So now we'll move ahead to the introduction to memory forensics. So when we talk about memory forensics, we are basically talking about the system memory that is present in the both physical form and the virtual form. So when we capture data from the memory of a system, that is what memory forensics entails. Now, what all information is there in the memory of a system? So each and every application that we are running, the application that the operating software of the system is running, they perform certain modifications in the memory of the system. So there are processes that are running in the memory of a system. So when we acquire those processes and that data from the memory, we gather some useful information. Now, what type of useful information are we gathering from a memory? So the useful information that we can gather from a memory of a system can be the uptime of a system, all the ongoing and terminated processes, and it can be the cache related data such as your clipboard data, the data that is if there's an encryption key stored in the system. So when we are when we are running the system and it is in the decrypted form, so the memory keys are temporarily stored in the memory. So if we are able to acquire data from the memory, there are chances that we may also acquire the passwords and the encryption keys that are stored there in the memory. It can also be the state it can also have data related to malware. So for the malware to function, it performs certain modifications to the processes that are running on the system. So it can be hiding in the memory of the system, and what are all network connections were open and the commands that were executed. So all of this data we can acquire from the memory of a system. Moving ahead to the advantages of memory analysis. Now we have acquired the data, but how is this data that we have acquired from the memory going to help us in our investigation? So one of the major advantages that we have is malware identification. So if a system has been compromised and we are able to find the traces of a malware within its memory, we are able to stop the infection from spreading further. And we mostly memory analysis helps us in the malware identification at the time of incident response. And what are the recent activities that the user was performing on the system. And we can also gather artifacts from, as we have already discussed in the introduction of memory forensics, data. It can also store information related to the chat messages that are not stored on a storage devices. So here is an example of how we need to analyze the memory and how the data is stored. So the data in memory is stored in the form of bits, and when we understand those and analyze those bits, we can gather information related to such as what all network ports were open when the memory was acquired. Now, it is also very essential to understand the fundamentals of memory forensics before we begin with the acquisition process. So what do we understand by the fundamentals? So in the fundamentals, we first need to understand what are the main components of memory forensics. So on a motherboard, there are many components that are there. It can have USB ports can be there. Hard drives are connected to the motherboard. CPU is connected to the motherboard. So the two main components that are essential, one is CPU and the another one is memory. that are connected to our motherboard. So how does they work? So the CPU, it basically gets the instructions from the memory that these are the commands that needs to be executed. And once the CPU gets the instructions, it executes those commands. And those commands are executed in the form of processes. Now, when we are acquiring a data, we move from the most volatile state of the data to the least volatile. So what do we mean by the volatile state over here? So when we talk about the volatility of data, it is basically as soon as we are going to turn off the system, that data is not going to be there. That means जैसे ही हमने power cut किया system का, वो data जो हमारा volatile data है that is present in a system, वो that will be removed from a system. So if we are at a crime scene and we are getting a system in a live condition, the first and foremost step that we need to take is to acquire the volatile data. So that when we move to the storage devices, because the data within the storage devices is not volatile, that is going to reside there even if we are going to turn off the system. But the volatile data will be removed as soon as we turn off the system, power of the system. So now we are talking about the volatile data, but what type of data is volatile? So volatile data basically comprises of registers, cache, and RAM. So RAM, as we know, it is random access memory, which is basically storing all the instructions. It is basically giving all the instructions to the CPU. It is a volatile memory. So as soon as we turn off the system, the data that is stored in the RAM will be gone. So the first and foremost step is to acquire the data from a RAM if we are getting the system in a on condition. Next is cache. So cache is just a form of memory, fast memory basically. What it does is cache resides on the CPU. When a system is communicating, so CPU जो है RAM से communicate कर रहे हैं, instructions ले रहे हैं, but जब तक data RAM तक पहुंचता है, it takes a lot of time. So what, as the technology advanced, there's a new technology came up, that is cache. What cache does is, cache जो है हमारा, it is residing within the CPU itself. It is using its cores, and within that core, it is storing some part of the processes that are actively getting used. So जैसे CPU को कुछ command execute करना है, वो command execute करने के लिए it can get the instructions from the cache, and जितना fast उसे वो instructions मिलेगा, उतना fast वो proceed, उसका function हमारे जो applications है, they are going to work smoothly and they are going to go load data smoothly. So these are the factors that also affect the performance of a system. So the concept of cache comes from there, and because cache is also storing some memory, that some data is getting stored in cache itself, so it also becomes important, and it is also a volatile data because अभी जो process run हो रहा है हमारे system में, उसके वो ही data हमारे cache में store हो रहा है. And lastly, the type of data that we are going to cover is registers. There are also very small amount of extremely fast memory. Registers just store a part of a process. Entire process is not stored on registers. So it is basically a temporary storage that is used at the time of processing. Now we have understood about what is a volatile data, what type of data is volatile. And we are also discussing a lot about the processes. So what is this process mainly we are talking about? So ये process जो है एक whenever we are running an application, let's take an example कि मैं अपने system में एक PDF viewer है Adobe run कर रही हूँ. Now the moment I open the Adobe and I open a PDF in my system, a task is going to be performed. A process is going to be performed. So if I'm copying any data from there, that itself is a process. So all of this information, if I'm copying any data from that PDF, so that will be saved, that data is going to be saved on the clipboard. So that clipboard data is going to be saved in the memory, and so that I can copy paste that data into another application or into another Word document. So a process is just the instance of a program. एक program हम run कर रहे हैं, उसमें जो हम activity perform कर रहे हैं, those activities are processes. जो हमारा execution जिसका memory that instructions are stored in the memory and the execution is done by the CPU. So now it becomes essentially important for us at the time of acquiring the memory that we have access of all the processes that are running at that moment. Now, as we have discussed earlier as well, that the data that is stored in the memory can entail passwords, encryption keys, chat logs. So when we are acquiring all of those processes, then it helps us in further like developing the case and understanding the events that might have happened. So this is what a process is. Now, each process requires a certain, like, the process is further broke down into different threads. So what are these threads? These threads are the basic units that CPU utilizes for the execution. Now, from these threads, the important information that we can gather is that of timestamps and the starting addresses. So if a process has started and a process used a certain thread, so what time the process used that thread and what was the starting address in the memory from where that thread process began. So this helps in further like at the chain of when we are creating the events, so that events we are able to create after acquiring the data from a memory. Now, this is the physical memory. The concept of virtual memory comes. So, हमारे system में there's a limited memory only. Now we are running so many processes on our system. We may encounter at times that हमारा system slow down हो जाता है. Why it is slowing down? Because there are certain processes that are using huge resources of our system. What do we mean by using huge resources? Huge resources as in हमारे system का जितना भी memory है वो continuously use कर रहा है for processing something. हो सकता है let's suppose हमने एक software use कर रहे हैं. It's a forensic software that is acquiring data from a device, from a mobile device. Mobile acquisition हम कर रहे हैं. So that process, that mobile acquisition process is actively running, and it is the application that we are running. That application is using huge amount of memory of a system to store that files temporarily. So now when our system is used in this way, and we have to run another application, what our system does is जो हमारे एक्टिवली प्रोसेस रन नहीं हो रहे हैं उसको एक वर्चुअल मेमोरी की तरह हमारी स्टोरेज डिवाइसेस में वो स्टोर करता है. और जब वो हमारी स्टोरेज डिवाइसेस में स्टोर होती है प्रोसेसेस, सो दोस प्रोसेसेस आर स्टोर्ड इन द फॉर्म ऑफ पेजेस, सो दैट हमारे जो एक्टिवली अभी प्रोसेसेस यूज नहीं है दोस प्रोसेसेस रिसाइड इन द सेकेंडरी स्टोरेज, सो दैट जब उनका यूज होगा those processes will be called, a system call will be made, and those processes will come back into the RAM of a system. Until then, they will be like stored in the virtual memory. Now, this was the concept of virtual memory. There's another concept of shared memory that is used for conserving the physical memory. So what do we basically mean by shared memory is that हो सकते हैं there are multiple processes which are using certain data which is common. It can be the link, the libraries, dynamic libraries that they are using, or the code they are executing, that they have some common data. So such processes, what they do, instead of creating a different page for each and every process, if there's certain common data, they utilize that common data. So instead of having multiple pages, a page which is having this common data, those processes will be linked or mapped to that specific page. So if there's any modification done at a later stage, there's this concept of copy on write. So whenever this kind of like the process can be updated or there can be modifications made to a process, अगर उस process में कुछ modifications होगा तो उसका page जो है वो भी modify होगा. So it is continuously getting mapped and the data is getting continuously read that if there's any changes being made. Now, apart from this, if we are acquiring data from a storage device or from a disk, we talked about the page files. So those page files reside on the system, like file system of a system. So apart from the page files, another artifacts that we may come across are the crash dumps and the hibernation files. So crash dumps can be created when there's a blue screen of death, that is BSOD occurs on our system. So a crash dump is created at that point of time. And hibernation files are created when the system is kept on hibernation. So basically, at the time of hibernation, the system resources are cut down so that the power the to minimize the power usage, the system resources are cut down, and the system is set in hibernation. Only the important system files are running at that point of time, and the processes that are actively using certain resources, those will be running. So these files are stored on a file system. So when we acquire data from a drive that is containing the OS operating software, so that drive we may be able to come across these files. So again, the procedure for acquiring the data from a disk is similar, that we have to create an image using we can either do a live boot, or we can use the imaging tools, software or hardware tools, to copy the data through imaging. So this was all about the fundamentals of memory forensics. Moving ahead, now we will come across the next thing we are going to discuss is the steps in memory forensics. That is, what are the steps that we need to follow in memory forensics? Just in disk forensics, may we have that first we have to acquire the data. First we seize the device, then we acquire the data, then we analyze the data, and a report is created. In like general terms, if I say. Similarly, for memory forensics, the first step is to acquire the data. That is, the raw memory will be acquired. And along with that, if there's hibernation files residing on the system, page files, crash dumps, all of that data will be acquired. Then we have to establish the context. That is, what type of data are we actually looking for? Is it related to a malware? Are we looking for any encryption keys in the memory, that dump that we have created? So we have to establish the context, and accordingly we have to find the memory offsets where we need to find that data. Once we have established the context, the next step comes is for analysis. So we are going to analyze the data for significant elements and recover the evidence from the memory. Now, today's session is only on the acquisition part, so we are not going to cover the analysis part, but we are going to establish the basics of memory forensics and what are the important steps in acquiring the data through memory. So these are the steps in memory forensics. Going ahead, we are going to talk about the live memory acquisition. So जैसा अभी हमने starting में भी discuss किया, what is live memory acquisition basically? जब हमें system एक live condition में मिल रहा है, that is, it is in power on condition. So उस condition में हम data collect कर सकते हैं from the system, and when we are at the crime scene. Apart from that, हमें जो basic procedure we have to follow that. We have to first maintain a chain of custody. We have to barricade the crime scene. We have to photograph and videograph the entire crime scene, and the condition of the system should be noted down. Once these things are done, and we have removed the system from if it is connected to the internet, we have disconnected it from the internet. And then we have to acquire the memory, because as we have discussed at the very beginning, that we acquire data from the most volatile to the least volatile. And memory is the most volatile data. So first we are going to collect the memory, and then how we are going to collect the memory is basically, this is the volatile data. So we are going to dump this data into a non-volatile storage device, so that we are at a later stage we are able to preserve this and we are able to investigate it further. Now, because it is a volatile data, जैसे हमें सिस्टम लाइव कंडीशन में मिला, हो सकता है उस पर कोई प्रोसेस रन कर रहा हो, कोई एप्लीकेशन रन हो रहा हो, कोई कॉपी फंक्शन चल रहा हो. So in those scenarios, because there's actively some processes running on the system, so there's actively changes being done to the memory of a system, because it is actively using the resources of the system. So there are chances that the alteration to the data that at the time जब हम crime scene पे पहुंचे, उस time से लेके जब हम acquire कर रहे हैं data, उस time तक कुछ changes, modifications memory में हुए हो. इसलिए when we are at the crime scene, we have to make sure that we are not in any way tampering with the data. And when we are acquiring the data, we have to be very careful on like how we are acquiring the data, the process how we are acquiring the data, because the RAM can be affected adversely at the time of acquisition. Now, as we were discussing that so memory hai, because the processes are actively running, so they can be hampered and alterations can be done to the memory. So what are the factors that are basically affecting the memory acquisition? So in a like traditional, agar hum racial forensics ki baat kare, it is suggested that if the system is in power off condition, so because we हमें कोई modification नहीं करना, हमारा data tamper नहीं होना चाहिए in any way. We just need to copy the data from the drive. So we shut down the system and we create an image of the system. But as we like advance further, and because of the technology's advancements, we are understanding that a lot of data is stored in the memory of a device as well. So if we are simply turning off the system and acquiring the data from the disk of a system, we are letting go of a very important data that we may acquire from the memory of a system, which is a volatile data. So first we need to ensure, like when we are at the crime scene, whether the system in front of us is having if it is a virtual machine. If it is a virtual machine, then we have a privilege of using the functions of a virtual machine that allows us to pause the virtual machine in its current state. We can clone the virtual machine, and all the resources that are provided to us by the virtual machine, we can utilize those resources for acquiring the memory from a virtual machine. Now, if it is not running a virtual machine, then we have to first identify whether the system is in running condition, that is whether the system is power on or it's in power off condition. Even if it is in power on condition, तो क्या वो actively वो कुछ run कर रहा है या वो hibernated state में है? अगर hibernated state में है, so again we first unlock the system, then the volatile data will be there. But until then the system is in hibernation state, वो सारा data जो है उसका hibernation file में save हो रहा है. So if the system is not actively running, so we can acquire data from the hibernation file, page files, and the crash dumps. If the system is actively running, then we need to get the root access. That means we need to have the admin privileges to be able to acquire data from the software tools. If we do not have the admin privileges, then we can either brute force the password of the system. We can exploit the vulnerability of the system to gain the root access and then acquire the data using software, or we can go through the hardware approaches. But hardware approaches are not that simple, because one, हमारा hardware पहले से installed होना चाहिए हमारे system में to be able to use that hardware for extracting the memory of the system. And two, अगर हमारा hardware installed भी है, then they are for the type of memory, like whether the store memory is more than 4 GB or less than 4 GB, whether we have the tools to acquire the data using the hardware, we have the knowledge to acquire the data using hardware, plays an important role. So again, as I've discussed about in the previous slide, how at the crime scene, acquiring the memory becomes essential for us. And these are the various questions that we need to first ask, whether there's a virtual machine running, whether the system is in current state. If it's hibernating, then we have to just basically we can take the dump of the file system. That is, we can create an image of the file system or the drive, and we can get the hibernation files, page files, and crash dumps from there. If the system is not in hibernation mode, and that is, it is actively running, we can acquire the volatile data. Again, there are many factors on which the acquisition of a volatile data depends. So when we are acquiring data from a system that is in unlocked state and we have the admin privileges, still there are certain factors that are going to affect the software-based acquisition. There can be factors related to remote versus local. So what do we mean by remote versus local is that whether we have the physical access of the system or not. because there might be situations कि हमारे पास physically system is not present, or the system is a server which is there in any network room or somewhere where we do not have any keyboard or monitor attached to the system, and we are not able to basically access the system physically. So in these situations, the only option that we have is that of remote acquisition. That is, we have to acquire the data remotely over the network. Again, when we are acquiring data remotely over the network, there are certain challenges that we may face, and whether, because when we are acquiring data over the remote, हो सकता है हमें कुछ agent install करना हो, कुछ service run करना हो system पे, and when we are running those processes or the services on a system, that is the target system from where we have to acquire the data, it is going to make certain changes to the RAM. So again, because वो RAM में process run हो रहा है, so the instructions will be sent to the CPU that this is the process that needs to be run. So there are going to be certain footprints that are going to be left behind. So when we are using such resources, we have to make sure we are mentioning each and everything in our chain of custody, that these were the steps performed because we do not have any other option. Next, a factor that is going to affect the software-based acquisition is the cost. That means we may not have the budgeting to buy the softwares that can help us in acquiring the data without that by leaving the least footprints on the target system. The format in which we are going to acquire the data, it might happen the analysis tool that we are going to use for the analysis of that memory dump. That format is not supported in the software that from where we are going to perform the analysis. Then there are challenges in the command line versus GUI, so graphical interface. It might happen that the investigator is more confident in using the graphical interface than the command line interface. And it is known that the graphical interface mostly leaves more footprints behind than the command line interface. But it also happens if your command line interface is not like up to the mark, or it is not as good as the graphical interface. So it is also possible that the command line interface also can leave more footprints than the graphical interface. And then acquisition versus runtime interrogation. That means whether we have to acquire the entire memory dump, or we just need certain processes or certain network connections to establish that. जैसे अगर corporate environments की बात करें हम, so we just need to understand whether इस जो हमारा suspect system है उसमें ये specific network port कभी open हुआ था या नहीं हुआ था. So when we are acquiring the volatile data from the system, हमें एक स्पेसिफिक क्वेरी को आंसर करना है. उसके लिए हमें पूरा फिजिकल उसका जो मेमोरी डंप है वो एक्वायर करने की जरूरत नहीं है. सो वी हैव टू बेसिकली अंडरस्टैंड द क्वेरी दैट वी आर गोइंग that has been asked and that we need to answer, so to be able to understand what process, how we are going to proceed with the memory acquisition. Now when we have understood like the fundamentals and we have understood the factors that are affecting the memory acquisition, now we move ahead to understand when and how we need to acquire the memory. So it is also very अभी तक मैं जब आप डिस्कस कर रही हूँ, so it is important कि हम कब acquire कर रहे हैं memory को, because time plays very important role. जैसे मैंने आपको बताया एट द क्राइम सीन हो सकता है कोई प्रोसेस एक्टिवली रन हो रहा हो हमारे सिस्टम पे जो हमारा सस्पेक्ट सिस्टम है, एंड एट दैट टाइम वी कैन नॉट एक्वायर द मेमोरी. क्यों नहीं कर सकते? बिकॉज जब वो कुछ फंक्शन परफॉर्म कर रहा है, सो दे आर कंटिन्यूसली मेमोरी में चेंजेस हो रहे हैं बिकॉज ऑफ दोज मॉडिफिकेशंस. अगर हम अभी एक्वायर करेंगे मेमोरी, सो हो सकता है जो हमारा डंप है वो करप्ट हो, क्योंकि when we have started the acquisition और जब हमने स्टार्ट किया acquisition, तो उसके बीच में कुछ processes थे that were not like dump में अभी वो copy नहीं हुए, because of that वो corrupted है हमारा dump. So we have to plan our acquisition in a way. अगर हम किसी सस्पेक्ट के कंप्यूटर से एक्वायर कर रहे हैं डेटा, तो सस्पेक्ट जो है वो ऑनलाइन होना चाहिए या लॉग्ड इन होना चाहिए, और एज एन एडमिनिस्ट्रेटर अगर लॉग्ड इन होगा, सो इट विल हेल्प अस फर्दर सॉफ्टवेयर के थ्रू एक्वायर करने के लिए. अगर हम किसी विक्टिम का एक्वायर कर रहे हैं, सो वी नीड टू मेक श्योर वी हैव टू अंडरस्टैंड कि अगर विक्टिम एज इन हो सकता है जो हमारा विक्टिम का सिस्टम है दैट हैज बीन कॉम्प्रोमाइज्ड. So to understand when the suspect is actively communicating with the victim's computer, we have to like find a time frame. So we have to monitor the network of the victim system to understand when the suspect is not actively uh, in touch with the victim system, and then we have to acquire data. And if possible, we should avoid collecting memory evidence during the period of drastic changes, such as when the system is starting up, when the system is shutting down, and when the system are performing maintenance tasks. If there's this fragmentation, virus scan is running, or a system backup is running, during these times, we should avoid acquiring the memory. And when the memory acquisition is being done, it is also not recommended to interact with the machine at that point of time, because again, that changes will be made to the memory, and we may end up having a corrupt image of the memory, corrupt memory dump. Now, how we are going to acquire the data? So as we have discussed, we are going to acquire the volatile data into a non-volatile storage, that is into a storage disk. It can be a hard disk, it can be pen drive. So in the storage devices, basically, we are going to acquire. It can be on a network location as well. So when we are acquiring the data locally to a removable media, we are basically what we are doing, we are connecting an external media to a target system. It might happen that the target system is infected. If the target system is infected, that means it is going to infect my storage device as well. So during these scenarios, there are certain things that we should keep in mind. That is, we should never attach the removable media to more than one possibly infected computer. तो अगर एक सिस्टम हमारा इन्फेक्टेड है, उसमें हमने अपना रिमूवेबल मीडिया कनेक्ट करा है, उसके बाद उस मीडिया को हम किसी और सिस्टम में जो इन्फेक्टेड नहीं है उसमें हमें कनेक्ट नहीं करना, किसी भी और सिस्टम में हमें कनेक्ट नहीं करना, बिकॉज इट कैन प्रोपगेट द इन्फेक्शन फर्दर. When we are working on a workstation, on a forensic workstation, we should not connect the removable media directly to it, जिसमें हमने infected system का memory dump collect करा हूँ. Again, क्योंकि मेरा external media possible है chances कि वो भी infect हो गया, and it can then infect my forensic workstation as well. So if I just need to like check whether I have to perform an analysis on the memory dump that I have collected from an infected system. So what I can do is I can use a system. I can basically create a system environment where I can just copy that evidence file and I can isolate it from the network, so that वो एक आइसोलेटेड मशीन है, आइसोलेटेड एनवायरनमेंट में मशीन है जिसपे मैं अपना एनालिसिस परफॉर्म कर सकती हूँ, सो दैट मेरा फर्दर प्रोपोगेट ना हो इन्फेक्शन, and it is not basically hampering my day-to-day activities. And once we are done with the analysis, we are saved a copy of our acquired evidence, acquired memory evidence, it is suggested to sterilize or erase or wipe the drive forensically, so that if we are going to use that drive again for another acquisition. Next step about how we can acquire the memory is through remote acquisition. So as we have discussed earlier as well, there can be scenarios जब हमारे पास option ही नहीं है कि हम सॉफ्टवेयर्स या हार्डवेयर के थ्रू मेमोरी एक्वायर कर सके. सो सिनेरियो में हमारे पास एक ही ऑप्शन बचता है, दैट इज ऑफ रिमोट एक्विजिशन. सो हाउ डू वी बेसिकली एक्वायर डेटा रिमोटली? वी आर बेसिकली जो भी हमारा एजेंट है या टूल है उसको हम नेटवर्क के थ्रू पुश करते हैं टू द टारगेट मशीन, एंड दैट within that tool we can schedule a task or a service जो हमारे टारगेटेड सिस्टम में इंस्टॉल होता है, रन करता है, and it can acquire the physical memory back. Now, there are certain issues with this type of acquisition. That is, it can expose the administrator credentials and the contents of the target system. क्योंकि हम over the network जब share कर रहे हैं, तो it is not encrypted in the encrypted format. तो अगर encrypted format में हम नहीं share कर रहे हैं, और हमारा जो application है, जो server है, that is not encrypting the data over the network, so there can be a man in the middle attack. That means someone can sniff the packets and they can understand कि इसमें हमारा कुछ essential information है related to the credentials of the system और हमारी RAM की contents है, and they can perform analysis on that and gather the information. So it is not entirely a safe process. And they can, from that memory dump, they can acquire the authentication tokens further, and they can perform the password hash attacks on it, and our system can be compromised in this way. So what we can do is we can create a temporary admin account on the target system that allows us access to the target system, and we can acquire the data from there. And once we have acquired the data, we can disable the temporary admin account, and we can also check further that no one is able to access the temporary account credentials anymore. And as we can see, there are many disadvantages of remote acquisition. So it should be our last resort when we have no other option to proceed with any other, like we do not have any other option to go with. Also, if so different tools, basically what they do, they acquire memory in a different formats. Agar so there's a tool, magnet axiom. अगर हम magnet axiom का use कर रहे हैं, it can like what it does is it captures the memory in the form of a zip folder. So when we're acquiring the zip format, we can perform a compression on the evidence. So before we are transferring over the network. So why are we compressing? Because one, it reduces the time and also the bandwidth that is required for the transferring of the data. जितना ज़्यादा हमारा data होगा, उतना ज़्यादा उसे time लगेगा और ट्रांसफर होने में over the network, because वो हमारी network bandwidth पे भी depend करता है. And also जैसे हमारे disk forensics में होता है, that we we calculate and verify the hashes before and after the acquisition. So similarly, in memory forensics also, we should compute the hashes before and after the transfer has been performed when we are collecting the data remotely. So that जब हम transmit कर रहे data, during that transmission कुछ changes ना हुए हो. The last step is runtime interrogation. So as we have discussed earlier as well, in a corporate environment, हो सकता है कि we are not interested in to analyze the entire physical dump, बस हमें कुछ processes check करने, whether those processes were actively running on the system or not, whether there was this malware infection on the system or not. Because how does malware work is basically वो हमारी system की memory में जाके execute होता है. तो अगर malware run हुआ है तो वो execute हुआ होगा. अब अगर वो execute हुआ है तो execution के लिए CPU and memory का यूज हुआ है, एंड दैट प्रोसेस वो अगर किसी प्रोसेस को मॉडिफाई भी कर रहा है, सो दैट इंफॉर्मेशन विल बी देयर इन द मेमोरी डम्प. सो if we are only looking for certain queries, we are not interested in acquiring the entire physical dump. So we can, for saving our time, we can use the enterprise level solutions जो हमें for that are provided to us by tools like F-Response, Access Data Enterprise, that is FTK Enterprise, Encase Enterprise. So these solutions have the capability to only capture the processes and not the entire dump. We can also like collect the entire dump using these tools, and we can also collect the processes. Lastly, through hardware acquisition that we have already discussed further. Now coming to the software tools, that what are the tools available to us using which we can acquire the data. So these are there are certain open source tools available. There are certain commercial tools available to us using which we can acquire the data. One of them, like F-Response, Encase Forensics, Wilcasoft. These are all commercial tools. Windows WinPM is an open source tool. FTK Imager is a commercial. Oxygen Fuzzy Retrieve is a commercial tool. OS Forensics, Magnet Update, and Magnet App Capture. So from these, we are going to look at some of the tools, that how do they work and how we can use them for acquiring the data. So first we'll look at the FTK Imager. What we can do is we can create a portable of FTK Imager within a pen drive. So I have the portable version of the FTK Imager. FTK Imager runs on Windows only. So basically we can acquire the memory from a Windows system only. What I need to do, I just need to run this application, and it is portably running on the system. And the application is running. So if I go to the task manager and I'll show you, As we can see within the application, it has enlisted that FTK Imager is running, and it is acquiring, like some of the memory is being utilized by the this tool as well. So even though I'm running this tool portably, but still it is acquired using some amount of memory to execute itself. So when we have to capture the memory, we just need to click on this capture memory option. We have to give the destination path. So because this portable is in my pen drive, so if my system, the system on which I'm acquiring this data is the target system, I just need to connect this pen drive to the system, and I need to maintain a log of the same, because जैसे ही मैं अपना system से pen drive को connect करूँगी, system में registry entry होगा, and that entry जब हम उसको acquire करेंगे उसका disk and analysis perform करेंगे उस data पे, so that entry will be reflected over there. So because if we have this entry is because we will have to capture the memory of the system. So we have to make proper notes, and we have to mention each and everything what we are performing since the time we reach the scene of crime, that these are the steps that we performed, and each step should be noted, and the chain of custody should be maintained. So and the format in which this FTK Imager creates the dump is .mem format, and it also gives us the option of including the page file. So as we discussed in the theory, so we can include the page file. So just to show you where the page file is. Because these are system files, so they are hidden by default. So to be able to view these files, you have to make sure that in the view section, we have like enabled that we have to view these files. So because these are protected operating system files, so they are already hidden. So once I select this, I can also create the memory dump in the format of AD1. So AD1 format is exclusive to FTK. So I can use this file and analyze this file in the FTK forensic toolkit later on if I want to capture it. So I'll just cancel this process over here because I just had to show you how to acquire the data. Next, we'll move on to OS forensics. In OS forensics, we have this option of creating a portable. So for creating the portable version of the OS forensics, I need the key. So if I have the key, then only I'll be able to create the portable version of OS forensics. So as we know that in OS forensics, we have this option of auto triage. So basically what is auto triage? Triaging basically allows us to gather information from the system before acquiring all of its file system. तो हमें पूरा फाइल सिस्टम एक्वायर करने की जरूरत नहीं है, जस्ट हम कुछ स्पेसिफिक इंफॉर्मेशन अगर हमें चेक करना है कि वो हमारे सिस्टम में रिसाइड करती है या नहीं करती है, वी कैन परफॉर्म अ ट्राइज and gather that specific information. And when we're performing the triage, we have this option of creating a memory dump. So if we select this option, a memory dump will be created. Now, when we are creating the portable version, I have this option of enabling auto triage standalone mode. So I have created portable using this method as well as disabling this method, this option. So I'll just show you how this option works. So this is my pen drive in which I have created the portable version of OS Forensics. So this was this portable version was when I have enabled the auto triage option. That at the startup, the triaging will enable automatically. So I do not have to, when I run this portable version, so as soon as the application runs, I can see again in the task that a new process has been created for that specific application. And because it was in automatic mode, so it has automatically started capturing the physical memory of the system. And it is also showing me the time that it is going to take. I'll just end this process from here. And I created another portable version of this where I disable the option of automatically triaging. So when I create a portable by disabling the automatic triage mode, it is going to run the application. It's taking time to load. Till then, we can move ahead to the next tool. We'll look at the magnet RAM capture now. Again, so all of these three tools, FTK Imager, OS Forensics, and magnet RAM capture, we can use these tools for capturing data, memory data from a Windows soft system. So once this application runs, as we can see, the amount of memory it is using is least compared to the FTK and OS Forensics. I can, if I want to create different segments, like I want to split the image in segments, I can do that. And I just need to select where I need to want to save this memory. And the memory is saved when I'm capturing the memory using magnet RAM capture, the memory is saved in the raw format. So I just need to give the location, and once I've given the location, I just need to start the acquisition of the memory. So there's one more utility. So these were all like magnet RAM capture, OS forensics, and FTK Imager. FTK Imager is like it's commercial, but it is free tool that is available to us. Similarly, magnet RAM capture is also a commercial and free tool, but OS forensics is a commercial tool. So we need to have the key to be able to create a portable and be able to acquire the memory data. Next. So, Oxygen Forensic Detective is a commercial tool which has a module of Oxygen Forensic Key Scout. So, what I can do is I can add it to a removable media. I just need to select the folder. I can add it there, and I can run this on Windows, Linux, and Mac systems. So, since my system on which I'm running it right now is a Windows system, I just go over here. The key scout module will open. So I can, if I have created a portable of the same, I can select that I'm running it on a live system. And when I'm running it on a live system, I have the option of capturing the RAM. I'll just click on this option of capture RAM, and it is going to save the image in the format of .bin. So as we can see, FTK creates .mem format, .bin format is created by Oxygen, and .raw format was created by Magnet. So each software that we are going to use for acquiring the data will create the memory dump in a different format. And again, the software that we are going to use for analysis may or may not support the format in which we have created the dump of the memory. So it is essential that we create or convert the format to the one that we want. So this is what we can do using Oxygen Forensic Detective. Lastly, we look at the magnet dump it. So magnet dump it is for both Windows and Linux. So I have created a VM over here in which I was going to create the dump it. So first we need to compile the magnet dump it to be able to use it. So yeah, on our forensic workstation, what we can do is we can compile this. So first, before we start with the compilation of the same, what we need to do is we need to install the Git on our system on which we are going to create this package. Once the Git is installed, we need to download the dump it files. So to do that, we are going to use the command git clone, and we'll go to the GitHub, and we are just simply going to copy the link for the dump it, magnet dump it for Linux from the GitHub page. Once we have copied, we'll go back to the terminal, and we are just going to enter that link over here. Once you've done this much, the files for dump it will be downloaded. After doing that, all the steps to compile this application is there. Once we have downloaded, the next step we have to do is we have to install Rust. So to install Rust, just follow this link. And what we need to do is just need to copy this command. So we just need to follow these steps, and we need to compile that. So we just need to follow the on-screen steps first. Till the time this is completing, if there's any query, you can write in the chat box. So once the Rust is installed, what I need to do next is I just need to run the cargo build release command. No, this installation we are going to do on a forensic workstation that I'm showing you currently, because first we need to build this magnet dumper for Linux needs to be built. Once that build is complete, then we just need to copy that file on a pen drive, and then we can create a portable and connect it to the target system. I hope your query has been answered. Meanwhile, this is completing. As I also told you about this OS Forensics portable that I created by disabling the auto trace feature. So if the when I was creating the portable, if I disable the auto trace feature, this will open the OS Forensics window. And within that window, what I need application, I can select the auto trace option, and within the auto trace option, I have the option of capturing the memory. Or if I'm like doing a live acquisition, I can also use the memory viewer to view the memory. And for analysis also, OS Forensics is comes with the volatility workbench, which we basically use for the analysis. So I can do a live analysis, what all processes are currently running on my system, and I can gather the information for the same. I can also have a do a static analysis. So over here, I just need to dump the file that was created. So these are formats: mem, bin, img, dmp format for the memory dump files that are supported in OS Forensics. So I can just dump these files over here, and I can perform the static analysis as well. So once this is done, next thing I need to do. So as I can see, a folder for Dumpit Linux has been created. I just need to change the directory to this folder first, or I can directly open the terminal over here. So once this is has been done, I can now use this command. So this is the command that is dump it for Linux that I need to use. And these are the various options that I can use. So I'll just show it to you. It is, I think the system is not responding right now. So I built the cargo, but I didn't build the dump it for Linux right now. So first I need to go to the location where the dump it for Linux folder is, and then I have to create it. Once this package will be built, then I'll be able to use the command dump it for Linux to be able to capture the memory. I can see this folder target has been created now. It takes around some 4 to 5 minutes to compile the entire program. So till the time it is moving, these were the references. These are openly available books. So if you want to read further, you can refer to these books. And if you want to contact us, you can use our details, and you can either email us or you can also contact us on these phone numbers. So once it has been created, I can go to this folder. I just need to first go to the target folder. So I'll change my directory to the, okay. So I need to make sure that I am within this folder that is dumped Linux. And now we go to the folder, uh, the target. And within this target folder, there'll be a folder of release. So once I'm within this folder, I'll be able to see there's this release folder. So within this folder, the dumper for Linux is. So from here, I'll run the command. So there's some issue. First, I need to install this. So the cargo hasn't been basically installed right now. There were some issues. Some library package files were not there. So once I am able to like what all it will show me all the instructions on the terminal that these files are missing. So I'll have to first build those files. Once I build those files, I'll be able to find in within this folder there will be a dump it Linux file will be there. I just need to run that file, and this is the command that I need to use, sudo dot slash dump it for Linux, and I can also specify the format in which I want to uh, run this. So as I can see over here, so this is how the memory will be captured. So once it has been done, what I'll do is I just copy this folder, entire folder, stump in Linux folder onto my pen drive or the portable wherever I want to create this portable, and I can just connect that portable to my target system and then open the command line and or the terminal. I open the terminal and run this command to be able to capture the memory from a Linux based system. So that's all for today.